I have before you is a really good organizational chart. It's just missing the facts and it's missing the sketch. Okay, now what this is meant to get you guys to do is to start to kind of get to that next level where you're not just obviously watching me or not just, getting answers for problems, but you're starting to synthesize, you're starting to put this all together. Um, Most kids will use a full sheet of paper in their notes, like kind of the next page, probably even turn your notebook like horizontally, I guess landscape. And yeah, you just got to take a moment and just create the chart. Okay, so I'm going to be quiet and let you do that. But as you create the chart, especially when you write the limit statements, which are at the top, you want to start to think, what the heck does this mean? What does this limit statement mean? And that's going to be your class challenge. Can you fill in the chart? Okay, now it's kind of fun to, at least from my perspective, to watch you guys do this. And it only takes getting started. Pick one of them. Pick the one that, you think what that is talking about. Put it up on the chalkboard. The sooner you start to do that, the sooner you realize that as a class, you should have what it takes to be able to fill this out. But just like we did in the last class challenge, it's kind of on you now. Again, help each other. Come up to the chalkboard. If you think something's wrong, be nice before you erase it to the back. And again, just pick one of them. Because quite frankly, one of them does have to do with today. All right, so the students did satisfy the class challenge, but so you can see what's true. I hope you thought about some of this on your own. This is our main limit statement. The limit exists, and that would mean that the right-hand limit is the same as the left-hand limit. That is going to be, can be sketched with a situation where there's a hole in the graph, or maybe there's just a value right there. But again, a good old limit, and it exists. Now with our second one here, it's a vertical asymptote. That does mean the limit does not exist. But because the limit is equal to positive or negative infinity, we can be more specific and say it's a vertical asymptote. As we can see, the graph is going up or down to infinity at C. But this one's the horizontal asymptote, okay, because this time X is going to infinity, but the height is approaching A, or this is drawn on the board here, 3, but it should be Y equals A. So that's definitely a horizontal asymptote. Now this guy right here, this is like a power function. The limit does not exist because the graph just goes up or down forever. Be careful, that's not an asymptote, because here x is going to infinity, and so is the limit. Okay, and then our last one over here, the limit does not exist. Now that can happen at a vertical asymptote, but it also more generically happens when the left limit does not equal the right limit. And so when does the left not equal the right? Normally when you have one of these piecewise functions with two different pieces that are not approaching the same value. Okay, so make sure you have this chart. I hope that you thought about it before you just advance to this screen.